I just want to let you guys know that we've been on this unit for a while, so I just want to warn you guys, today's Tuesday. The tests will be given out on Friday. So we have today and we have Thursday, and then the test will be given to you, and then we'll go on to harder factoring. What happens when the number in front of x squared is not able to be factored out? In other words, you have to get a little bit creative. But fortunately, all these are either going to have the leading coefficient factored out completely, or it's just going to be 1. Okay? So in particular, factoring completely. So my first move, whenever I see directions that say factor, is can I take something out from all three of these terms? Yes, I can divide 4. So I'm going to factor out a 4 from all three of these terms. 4 times what is 4x squared? 4 times x squared is 4x squared. 4 times what is 24x? 24 divided by 4 is 6. So 4 times 6x is 24x. 4 times what is 36? Positive 9. But the directions say factor completely. So I'm looking to factor this individual part now. So factor and factor until you can't factor anymore. So I'm looking for two numbers that multiply to positive 9 and add to positive 6. So in particular, what does this tell me about the combination? Has to be a positive times positive. So let's get right to it. 1 and 9. 1 times 9 is 9. 1 plus 9 is 10. Let's try divide by 2. Well, that would be a decimal, 4.5. So forget about it. Let's try divide by 3. 3 times 3 is 9. 3 plus 3 is 6. So we have a winner on that try. So remember, I factored out the 4. And the winning combination is positive 3, positive 3. So this is 4 times x plus 3 times x plus 3. And I'm totally okay with that. But if you want to be fancy, and that's okay with me, if you want to be fancy, you can write this as, remember the 4 is factored out, but the x plus 3 times the x plus 3 is the repeater. So this could be x plus 3 quantity squared with the 4 factored out in front. Okay? Let's see if we can do something with number 2. Okay. All right, two numbers. Sorry, can I factor something out from all three of these numbers? 2x squared, negative 24x, and positive 54. Let's try dividing all three of these by 2. So if I factor out the 2, 2 times x squared is 2x squared. 2 times what is negative 24x? Negative 12x. 2 times what is positive 54? 2 goes into 54, 27 times. So now, I want to factor this part now. The x squared minus 12x plus 27. Two numbers that multiply to positive 27 and add to negative 12. Well, positive, positive, negative, negative, or one of each. Remember, don't fall for that, oh, it's positive times negative because it's positive here and negative here. If you're ever in doubt, look at the cheat sheet or cover up and go, okay, positive, positive, or negative, negative. Those are the only two ways I can make positive. Oh, negative, negative. So let's get right to it. Negative 1, negative 27. Negative 1 times negative 27 is positive 27, but negative 1 plus negative 27 is negative 28. Can I divide by 2? Can I divide by 3? Yeah. Negative 3 times negative 9 is positive 27. So let's try negative 3 plus negative 9. Oh, there's the winner. There's the winning team right there. So remember, I factored out the 2, and the winning combination was -3, -9. So that becomes x minus 3, x minus 9. So that is the completely factored form. All right. Number 3, 6x squared minus 30x minus 84. Okay. So, can I divide something from all 3 of these terms? You're going to see a recurring theme in this particular test. Yes, I can divide all 3 of these by 6. Six times x squared is 6x squared. 6 times what is negative 30x? That would be negative 5x. I'm going to get a calculator for this part because even I kind of struggle with this. 84 divided by 6 is 14. So 6 goes into negative 84, negative 14 times. So now we have a quadratic trinomial, x squared minus 5x minus 14. So I know I'm going to factor out the 6 over here and get some sort of x and x combination. So I'm looking for 2 numbers that multiply to negative 14 and add to negative 5. All right? Positive, positive, negative, negative, or one of each. So if I cover up this column over here, in order to multiply to negative 14, I need one positive, one negative. But which one's going to be stronger? The negative is going to be stronger. So that becomes a weak positive and a strong negative. 1 times negative 14. 1 times negative 14 is negative 14, but 1 plus negative 14 is negative 13. That's not what I want. Can I divide by 2? Yeah, let's try positive 2 and negative 7. Positive 2 times negative 7 is negative 14, but 2 plus negative 7 is negative 5, and that's the winning team. Positive 2, negative 7. So remember that we factored out the 6 in advance. So let's do that. The winning team is positive 2, negative 7. So factored out 6 times the quantity of x plus 2 times the quantity of x minus 7. All right. 3x squared plus 6x minus 144. Can I factor something from all 3 of these terms? Yeah, let's factor out the 3. So if I factor out the 3, I'm left with 3 times what is 3x squared? That'd be x squared. 3 times what is positive 6x? That would be positive 2x. And 144 divided by 3, I believe is 48. I'm just going to double check. 144 divided by 3 is 48, yes. So negative 144 divided by 3 is negative 48. Now I want to factor this quadratic trinomial. What 2 numbers multiply to negative 48 but add to positive 2? All right, just by looking at this, what can I tell about this combination? Well, it needs to be a positive-negative combination. But that plus 2 tells me that the stronger positive will be one of the factors. Weak negative, strong positive. So let's go with the first weak negative, strong positive combination. Negative 1 times 48. Negative 1 times 48 is negative 48, but negative 1 plus 48 is positive 47. It's not what I want. It's not even close, but we're going to get there. Can I divide by 2? Yeah, let's try negative 2 and positive 24. Negative 2 times positive 24 is negative 48, but negative 2 plus 24 is positive 22. Can I divide by 3? Yeah. Negative 3 times positive 16 goes into negative 48, but they add together to form positive 13. Can I divide by 4? Yeah. Negative 4, positive 12. Negative 4 times positive 12 is negative 48, but negative 4 plus 12 is positive 8. Getting closer. Can I divide by 5? No. Can I divide by 6? Yeah, let's try negative 6, positive 8. Negative 6 times 8 is negative 48, but negative 6 plus 8 is 2. There's the winning team. So we factor this. Don't forget about that 3. The winning team again was negative 6, positive 8. So that's 3 times x minus 6, x plus 8. Okay. And that is how you completely factor problem number 4. Ah, blast from the past. X squared minus 9. What kind of case is this? That's the difference of 2 squares. That's a subtraction problem involving 2 squares. And what is the difference of 2 squares always factor into? Straighten that tie. Straighten that tie. The conjugates. Specifically, the square root of 9 is 3. So this becomes x plus 3, x minus 3. Straighten that tie. We want to get to the conjugates. Okay. All right. Now, I'm going to throw a monkey wrench. I want to see if you guys can handle this. Well, number 6 isn't too bad because this is the difference of 2 squares. They're all going to be the difference of 2 squares. So in particular, what can I factor x squared minus 49 into? Conjugates. The square root of 49 is 7, so this becomes the conjugates x plus 7, x minus 7. Now I know what you're thinking, number 7. Part of me wants to divide something from both of these. So can I divide 4 and 25 by something? Like, let's say 2 or 5 or 4. No, I'm going to get a decimal. However, I could argue that this is still the difference of 2 squares. The square root of 4x squared is 2x. The square root of 25 is 5. So why don't I try to break this down? 2x plus 5, 2x minus 5 into conjugates. Because if I were to FOIL this out, you can FOIL this out by yourself. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Okay. 5 times 2x is positive 10x. And 5 times negative 5 is negative 25. Notice that the positive 10x and the negative 10x will cancel each other out. So the rule of the conjugates still applies, even though we have the difference of 2 squares where the coefficient in front of x squared is not 1. So let's take a look at number 8 and number 9. See if you have a good guess as to what these can factor into. Well, the square root of 36x squared is 6x, and the square root of 1 is 1. So why don't I break this down into conjugates? 6x plus 1, 6x minus 1, and if you don't believe me, you can FOIL it out for yourself. 36x squared minus 6x plus 6x minus 1. The middle terms cancel out. 6x minus 6x. They eliminate and form the difference of 2 squares. Now that you guys know how to do this, see if you can do the last 4 problems independently. Well, what's the square root of 49x squared? And what's the square root of 100? (7x plus 10, 7x minus 10), multiply them out, FOIL them out, and you will get the 2 conjugates forming the difference of 2 squares. See what you can do about this one. 121x squared minus 64. Well, what's the square root of 121x squared? Well, the square root of 121 is 11. So the square root of 121x squared is 11x. And the square root of 64 is 8. So I can factor these conjugates into 11x plus 8 times 11x minus 8. 11x times 11x is 121x squared. 11x times negative 8 is negative 88x. 8 times negative 11x, 8 times 11x is positive 88x. And 8 times negative 8 is negative 64. The middle terms cancel out, leaving me with 121x squared minus 64. All right, number 11 and 12. Let's see. What's the square root of 9x squared? 3x. And the square root of 49 is 7. So I'm going to break this down into 3x plus 7, 3x minus 7. And those are the conjugates. All right, and finally number 12. The square root of 16x squared is 4x. And the square root of 81 is 9, so I could break this up into 4x plus 9, 4x minus 9. And that's it for today. In fact, Thursday we're going to have a big review day where I'm going to put everything that'll prepare you for the test. Once again, please make that table yourself if you do not know the combination at the snap of the fingers, okay? So, know all 4 cases of factoring the multiply to C and add to B, and the difference of 2 squares. And that's it. Have a great day.